Hello guys, welcome back to my channel. Today we are solving problem E interview of Codeforces Round 859, and this is a very interesting problem. In my opinion, this is the most interesting problem of this contest. It's also an interactive problem. An interactive problem is one where you can basically interact with the judge. You can ask some queries to the judge, to which the judge will reply, and based on that you can find the answer. Right, so let's check what this is. We are given an array basically, and each index of the array has a number which denotes the number of stones we have. That is, here we have 1 stone in the first index, 2 stones in the second index, 3 stones in the third index, and so on. Now the thing is, each of the stones are of weight 1 except for one stone which is of weight 2, and we basically have to locate the weight 2 stone in the entire array. Now what can we do? We can basically interact with the judge in this format. I can query the weights of any number of stones that I like. For example, I can ask the weight of the stones 2, 3 and 5, and the compiler will give me the total sum, that is 2 plus 1 plus 1 plus 1 plus 1 plus 1 plus 5. So that's 3 plus 4 plus 5, so that's 12. So something like this. Now there's a limitation. We can only ask at most 30 queries and then we have to give the answer. Otherwise, we could have asked for every index separately and then just given the answer, but that is not possible. Only 30 queries we can ask. So how do we solve this problem? And how do we give an answer to the problem? If we are giving an answer, the answer has to start with an exclamation mark, something like this, exclamation 7. And if it is a query, it has to start with a question mark. So let's look at the explanation. Here I have taken the example. So we can choose any number of piles from these. For example, we choose the first and the second pile, and we give a query like query question mark 1 and 2. Then the compiler or the judge will return 1 plus 2 plus 1. So that is 1 plus 2 plus 1 is 4. And we can make similar queries, as many as we want, but less than or equal to 30. Now, how do we solve this? If you think about it, it would be very complex to start designing an algorithm in which we start asking random indexes to the compiler and then figure out something from it, right? For example, how would we decide that we want to know the sum of the weights of the first, second and fourth piles? It has to follow some pattern, right? So obviously we can't ask haphazardly. So there's some trick in this. The trick is identifying that there is only one anomaly, and we are given an array, and basically we have to find one anomaly, or we can also call it target, in a given array. Now I wonder what algorithm does this sort of a thing. An algorithm which comes to my mind is binary search. This is somewhat like finding a word in a dictionary. Suppose you want to find the word home in the dictionary. What do? You open a random page in the dictionary from the middle, and then you check if it contains words starting the letter H or not. If it contains, then well, otherwise you contain in the right or left half of the array, right? So here we are trying to do a similar kind of thing. So if we apply that logic over here, the correct answer is this, right? 2 is the correct answer, because on the second index the anomaly is there. But how do we find it? We take a left and a right pointer, and then we calculate the mid. Mid becomes here, and we can choose whether we want to calculate for left hand side or right hand side, but we can just ask the value for this part of the array as a query, something like question mark 3, because we want the sum of elements of a subsegment of length 3, and then the indexes, which are 1, 2 and 3, and that would return us with 1 plus 3 plus 3, which is 7. But with our own calculation, we have 1 plus 2 plus 3 is equal to 6. So there's a difference, right? That means the anomaly is definitely in this side of the array and not on this side of the array. Then we try to narrow down our search again. We cancel this mid and make it R, and now mid becomes here. right? And then we ask for this segment. So question mark 2, 1, 2. And we are returned 4, but our answer is 3. So we know that this is the correct place to be. So we cancel this mid and make it R. And then our mid becomes this. And then we do a query question mark 1, 1, 1, which means we are asking the sum over here. And the returned answer is 1, and our expected answer is also 1. So no difference. So that means this is not the correct answer, and then we should print this now that we know. So our final answer should be something like exclamation mark and then 2. This is precisely what we have to do. So let's look at the code. I'll look at my accepted solution. Over here, ignore the red parts, these are just commented out, I was debugging. And so here I've taken the array and I've made a prefix sum. Why have I made a prefix sum? Because I'm getting the actual sum of weights from the query, which is 7 in this case. So to get the actual sum of weights, this I'm getting from the query. But the expected sum of weights we will get by adding these, right? This plus, so basically the number of stones. So 1 plus 2 plus 3. Here this should be 6. So how are we getting that? If we start calculating by running a loop, we'll get TLE. So how do we avoid that? We use a prefix sum. So for an array 1, 2, 3, 4, 5, we can store 1, 3, 6, 10 and 15. And then to get this sum, all we have to do is 6 minus 0, because here nothing is there. And we use the same logic as we used in the previous question, that is D problem, prefix sum of R minus prefix sum of L minus 1. This gives you the sum of all the elements from L to R inclusive. So we make a prefix sum over here, and then we take L equal to 1 and R equal to N and calculate the mid every time. And we query all the elements in the range from L to mid, right? And then we input the actual sum, which is the query basically, and we calculate the expected sum. And if it is equal, then we move the L pointer to the right side, because the answer is not in the left side. Otherwise the answer is here only, so we bring the R to the mid. And as you can see, this is accepted. So yeah, thanks for watching. Please subscribe to my channel. See you in the next one.